Question 1. An application running on an EC2 instance needs to securely interact with an S3 bucket and a DynamoDB table. What is the most secure and recommended way to grant these permissions to the EC2 instance? Option A. Store AWS access keys directly in the application code on the EC2 instance. Option B. Create an IAM user with programmatic access and attach its access keys to the EC2 instance. Option C. Create an IAM role with the necessary S3 and DynamoDB permissions and associate it with the EC2 instance. Option D. Configure a resource-based policy on the S3 bucket and DynamoDB table that grants access to the EC2 instance's private IP. The correct answer is create an IAM role with the necessary S3 and DynamoDB permissions and associate it with the EC2 instance. Here's the explanation. Associating an IAM role with an EC2 instance is the most secure and recommended method. The instance can then automatically obtain temporary credentials from the AWS metadata service, eliminating the need to embed or manage long-term access keys directly on the instance, adhering to the principle of least privilege. Question 2. An IAM user has an identity-based policy that explicitly allows S3 get object on a specific S3 bucket. However, the S3 bucket policy itself contains an explicit deny for that user for S3 get object action. What will be the outcome when the user attempts to retrieve an object from that bucket? Option A. Access will be allowed because the identity-based policy grants permission. Option B. Access will be denied because an explicit deny in any policy always overrides an allow. Option C. Access will be allowed if the user also has MFA enabled. Option D. Access will be denied only if the user is part of a group with an explicit deny. The correct answer is access will be denied because an explicit deny in any policy always overrides an allow. Here's the explanation. In IAM policy evaluation logic, an explicit deny statement in any times applicable policy, identity-based, resource-based, SCP, permissions boundary, always overrides any allow statement. Therefore, the user will be denied access. Question 3. Which of the following statements about IAM groups is true? Option A. IAM groups are used to store temporary security credentials for AWS services. Option B. Permissions are attached directly to individual IAM users, not to groups. Option C. An IAM group is a collection of IAM users, and all users within the group inherit the permissions attached to the group. Option D. IAM groups are global resources that are unique to each AWS region. The correct answer is an IAM group is a collection of IAM users, and all users within the group inherit the permissions attached to the group. Here's the explanation. IAM groups are collections of IAM users. Attaching permissions to a group simplifies management, as all users added to that group automatically inherit those permissions. IAM users, groups, and roles are global resources, not unique to each AWS region. Question 4. What is the fundamental difference in how IAM users and IAM roles obtain and use credentials for accessing AWS resources? Option A. IAM users use temporary credentials, while IAM roles use long-term static credentials. Option B. IAM users authenticate directly with long-term credentials, while IAM roles are assumed by a trusted entity to obtain temporary credentials. Option C. IAM users can only access resources programmatically, while IAM roles can only access them via the console. Option D. IAM users are primarily for cross-account access, while IAM roles are for same-account access. The correct answer is IAM users authenticate directly with long-term credentials, while IAM roles are assumed by a trusted entity to obtain temporary credentials. Here's the explanation. IAM users represent a persistent identity with long-term credentials, password, access keys. IAM roles do not have their own long-term credentials. Instead, they are assumed by another trusted entity, which then receives temporary security credentials for a limited duration. Question 5. A developer is building a serverless application using AWS Lambda. This Lambda function needs to read objects from an S3 bucket and write logs to CloudWatch. What is the most secure and recommended way to grant the Lambda function these necessary permissions? Option A. Create an IAM user with access keys, embed the keys in the Lambda function code, and attach policies to the user. Option B. Attach an IAM role to the Lambda function, allowing the Lambda service to assume it and granting the required S3 and CloudWatch permissions. Option C. Grant full S3 and CloudWatch access to the AWS account root user and run the Lambda function under the root user's context. Option D. Define a resource-based policy directly on the S3 bucket and CloudWatch logs to allow the Lambda function's ARN. The correct answer is attach an IAM role to the Lambda function, allowing the Lambda service to assume it and granting the required S3 and CloudWatch permissions. Here's the explanation. For applications and AWS services like Lambda, using IAM roles is the most secure practice. The Lambda service assumes the role, which provides temporary credentials, avoiding the need to embed long-term access keys directly into the function code. This adheres to the principle of least privilege and enhances security. Question 6. Which component of an IAM role explicitly defines which trusted entities, e.g., IAM users, AWS services, or external accounts, are permitted to assume that role? Option A. The permissions policy. Option B. The identity-based policy. Option C. The trust policy. Option D. The resource-based policy. The correct answer is the trust policy. Here's the explanation. An IAM role consists of two main policies. The trust policy, which specifies who can assume the role, and the permissions policy, which specifies what actions the assuming entity can perform once the role is assumed. Question 7. An IAM user has an identity-based policy that grants S3 full S3 access. A permission boundary is also attached to this user, which only allows S3 get object and S3 list bucket. If the user attempts to perform S3 put object on an S3 bucket, what will be the outcome? Option A. The action will be allowed because the identity-based policy grants S3 *. Option B. The action will be denied because the permission boundary does not allow S3 put object . Option C. The action will be allowed if no service control policy, SCP, explicitly denies it. Option D. The outcome depends on whether a resource-based policy on the S3 bucket allows S3 put object . The correct answer is the action will be denied because the permission boundary does not allow S3 put object . Here's the explanation. Permission boundaries define the maximum permissions an IAM identity can have. For an action to be allowed, it must be permitted by both the identity-based policy and the permission boundary. In this case, while the identity policy allows S3 put object . The permission boundary restricts it, leading to a denial. Question 8. Which of the following statements about IAM permission boundaries is false? Option A. A permission boundary can be attached to IAM users and roles. Option B. A permission boundary explicitly grants permissions to an IAM identity. Option C. A permission boundary is always a managed policy, AWS managed or customer managed. Option D. The effective permissions for an identity with a boundary are the intersection of its identity policies and the boundary. The correct answer is a permission boundary explicitly grants permissions to an IAM identity. Here's the explanation. Permission boundaries do not grant permissions themselves. They only define the times maximum permissions that an identity-based policy can grant, acting as a biome, ceiling, or guardrail. They never add permissions, only restrict them. Question 9. A central security team wants to ensure that a delegated administrator can create new IAM roles, but these new roles can never have administrative privileges or access to specific sensitive resources. Which IAM feature is best suited to enforce this organizational guardrail on the new roles created by the administrator? Option A. Attaching an explicit deny identity-based policy to the administrator's role. Option B. Applying a service control policy, SCP, at the organizational unit level. Option C. Attaching a permission boundary to the administrator's role, restricting what policies they can attach to new roles. Option D. Using resource-based policies on the sensitive resources to deny access. The correct answer is, quote, attaching a permission boundary to the administrator's role, restricting what policies they can attach to new roles. Here's the explanation. A permission boundary attached to the administrator's role can restrict the permissions that the administrator themselves can grant to new times roles. This ensures that even if the administrator tries to create a role with broader permissions, their own permission boundary prevents them from assigning policies that exceed the defined maximum, effectively controlling the permissions of the roles they create. While SCPs are organizational, permission boundaries offer more granular control on specific identities for delegated administration. Thanks for watching. Please subscribe to my channel.